Notes 11.1, rational versus irrational and simplifying radicals. So this is our second to last unit this year, and I'm going to fill in that table. So you guys know what it means to square something. So it means to multiply it by itself. So in that first box, 1 times 1, or 1 squared is 1. 2 squared is 2 times 2, which is 4. Go ahead and we're going to pause the video, and I want you to fill in that chart without the use of your calculator. So you should have come up with 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, 225. Those in that chart need to be memorized. So now we're going to take this and sort of work the other way with it, because to undo something squared, we take the square root. Or to undo the square root, we square. So they're inverse operations. Just like the inverse of adding is subtracting, the inverse of dividing is multiplying. Well, the inverse of squaring is square rooting. So to take the square root of 81, we need to think in our minds, what times itself would give us 81? So what number times itself gives you 81? And obviously you've got your nice little chart up here to be able to see that the square root of 81 is 9. And then the square root of 25 is 5. Square root of 49, 7. 7 times 7 is 49. The square root of 225. Again, ask yourself that question. What number times itself gives you 225? 15. You have 13. But then all of a sudden we get to a number like what's in number 6, the square root of negative 81. Think about what I said. The square root is a number times itself. The exact same number times itself gives you what's underneath the radical. Can I come up with a number times itself that is going to give me a negative 81? So you might think to yourself, 9 times negative 9. But is that a number times itself? It's not, right? And then you might say, okay, well, what about negative 9 times 9? That gives you negative 81, but it's not a number times itself. These are opposites. And then somebody else might say, oh, well, what about negative 9 times negative 9? That's a number times itself, but a negative times a negative gives you a positive. All right? So this, can we come up with, and yes, we have a live audience today. This is my Syracuse class, so those of you that might hear some classmates talking, yes, they are answering some of these. So when you think about this, can you take the square root of a negative number? Is it possible? Okay? This right here is not possible for right now. About 4 years, 3 years, that'll be a different story. But when I look at number 7, is number 7 just like number 6? What's different about number 7? The minus sign is outside the radical, or the square root. So what's happening with that? We have a negative square root of 25. So what is the square root of 25? And you might be saying, well, I know that that's 5. Well, what's happening with that negative? It's really a negative 1 times the square root of 25. And you would know that that's going to be negative 5. Negative 1 times 5, okay, that becomes 5. So it's negative 1 times 5, which is negative 5. But now I go back to number 8, and it's negative, or square root of negative 49. The negative is inside the radical, so is that possible? No. Okay? Not possible. Number 9, same thing. The negative is inside the radical. Not possible. But in number 10, the negative is outside the radical, so that's like saying negative 1 times the square root of 169. And you know that the square root of 169 is 13, so negative 1 times 13 is negative 13. So we're going to move down to some definitions of some numbers and some examples. So I'm going to give you an example of a rational number. I'm going to give you a bunch of examples, and then we're going to come up with a definition. So here are a few examples of rational numbers. 1/2, 0.3, 0.585858, negative 18, 0, negative 3/17, 5. Lots of random numbers here, but I want to give you enough examples so that we can come up with our definition. The square root of 16. You know now that the square root of 16 is 4. 0.46. These are all examples of rational numbers. So what could be my definition for a rational number? It's any number that can be written as a fraction. And there's a couple things that we can add to that. Okay? If there is a repeating pattern, meaning a repeating decimal, that's a rational number. There's a pattern to it. And if it terminates, okay? And what does terminate mean? Terminate means it ends. Okay? An ending decimal. Doesn't go on and on and on. So, anything that can be written as a fraction. 1/2 is a fraction. Negative 3/17 is a fraction. 0.3, okay, is 3/10. We could write that as a fraction, 3/10. This has a pattern to it. Okay? Negative 18, I could write negative 18, I could make it a fraction and say negative 18/1. It's a fraction. 0. Put 0/1. That's a fraction. Same thing with 5. Square root of 16 we said is 4. 4/1. That's a fraction. 0.46. It ends. And I could also make it a fraction. 46/100. Hundredths. So these are all rational numbers. So now let's get some examples of sort of their opposites, irrational numbers. Most famous one, pi. Square root of 2. Negative square root of 8. 0.8432104 ... Some examples of irrational numbers. We know about pi. Right? There's no end to pi. It keeps on going, and there's no pattern to it. Square root of 2, okay, it's not one of our perfect squares that we learned about up here. We can't come up with a number times itself that's going to give us 2. Same thing with 8. We can't come up with a number times itself that's going to give us 8. Okay? No pattern to this, and ... means that it keeps on going. So, a definition for an irrational number, okay, it's non-terminating. Non-terminating. It's not terminating, so it doesn't end. Okay. So let's put that in parentheses. Doesn't end. And it's non-repeating. Non-repeating, so it doesn't repeat. No pattern. Okay? Doesn't repeat. I like to say that the irrational numbers are the messy ones. Okay? They're messy. The rationals are nice, neat. They have a pattern to them. Okay? All right, go ahead, flip the page when you're ready. And we're going to take some examples, okay, and determine are they rational or irrational, and then we're going to explain why. So the explain why is going to be the definition. So number 4. Who can tell me? Here it is.
Number 4 was rational.
Rational, and why is it rational?
Rational because we can make a fraction.
We can make it a fraction. Okay, I'm not going to write all these. R is for rational. Okay, we'll let you guys do that. And I is for irrational. Yes. Okay, the explain I'm going to have you guys just verbalize. Leah, number 12 is, that is pi. It just didn't. It's irrational. Why do we say that it's irrational? Could go on forever. Caitlin, number 5 or 13. Right, because the square root of 25 is? What's the square root of 25, guys? 5. Okay, so that's 5. It's rational. It could be written as a fraction. 14. Ma'am.
Rational.
Square root of 11.
Irrational.
Why is it irrational?
Because it can keep going.
It can keep on going. Type in square root of 11 in your calculator.
I got 3.3.
Right.
Yeah.
No pattern. Keeps on going. 15. 15. Come on, guys. Somebody else.
Oh.
Kevin.
I believe that this is rational.
Yep. Because what?
It's a fraction.
Perfect. Number 16. Mar.
Rational?
Because?
That's a fraction.
Perfect. 17. Darius.
That was going to be a pi, or the
No. Not pi.
Oh, it's irrational.
It's rational because it, does it keep on going or does it terminate?
Sure.
Terminates. And we can make it a fraction. We could say that this is 3 and 14 hundredths. Okay? This is rational. 18. Everybody.
It's rational.
It's just a really small number. That's all. There's no decimal there. Okay? It's a negative. That's fine. We can make that a fraction. And be careful in 19.
Irrational. It goes on forever.
But does it have a pattern? Is there a consistent pattern?
No.
Let's look.
It is. 1,
Yes,
0,
there
1,
is.
1.
Because there's an extra one. It keeps adding one each time.
101. 101. 110.
No.
11110. There is no pattern here. It's irrational. Okay. All right. I'm going to put a couple on here. Couple more. Stay right there. No, don't turn the page. I'm just going to put 2 more questions on here. The square root of 37, and it's not the same direction. I want to know what 2 integers is it between? What 2 integers is the square root of 37 in between? So talk to me for, well, I'll talk to you guys for a second. Do we agree that the square root of 36 is 6?
Yes.
Yes.
And would we agree that the square root of 36 is pretty darn close to the square root of 37?
Yes, it is.
Okay. The square root of 36 is 6.
Yes.
What is the next perfect square in line after the square root of 36?
37. What's the next?
Nothing. Say it again. Square root of 49. What's the square root of 49? 7. So what two integers is the square root of 37 in between?
6.5.
What is it in between?
7.
It's between 6 and 7. Which one is it closer to?
6.
6. Because is 37 closer to 36 than it is to 49?
Yes.
All right. And the last one. What number is less than the square root of 15? And I'm going to give this a little multiple choice here. I'm going to pause the video. I want you to use your calculators, and I want you to think about that one, come up with an answer. All right, so you guys can see that it is less than, okay, A, because we approximated all those with the use of our calculator to come up with those numbers, and the square root of 15, the number that is less than, is the square root of